right, good morning and good afternoon, everyone, depending on where you are. Welcome to a presentation by Akana, Microservices, Why Should Business Care? Hopefully everyone can hear me. I think we had some voice or audio issues earlier. We're also recording this webinar for later review, and a link will be sent out to everyone in a couple of days so that you can review it in your own time and show it to other people and share it. So I'm going to be talking a little bit about microservices and basically what this means. I think that there's a lot of misunderstanding about microservices and what they are. And also I'm going to try and touch on what it means to the business and what relevance that it really has in the marketplace. I think that people tend to get bogged down in the technology and don't necessarily understand fully what it means to the business, what value it can bring, when to use it, when not to use it, and what impact it's actually going to have on your IT organization. What exactly are microservices? Well, this presentation, because it's basically geared as to what do microservices mean to business, I'm trying to keep it at a high level here. So microservices are a new way to build applications. And essentially, it facilitates that by breaking them up into small independent services. There's a lot of detail into what exactly that means, which I'll get into later on. But it's not language specific, which is very important. So no matter what language you implement or using within your organization, you can implement a microservices architecture. There's frameworks and platforms out there that will help you and facilitate a lot of capabilities within that, but I'll get to that later. Suffice to say, it's not necessarily language specific. It also doesn't have a lot of heavy middleware. By very, very definition, microservice doesn't necessarily mean that it's small in size, but it certainly doesn't mean that you're dragging a lot of expensive middleware into the equation. The other thing is that most of the frameworks and platforms out there that do provide facilities for microservices are mostly open source. So let's get into this in a little bit more detail. When I talk about a microservices architecture, I'm referring to things that look a little bit like this. You have a registry in the top left-hand corner, and this is a place where you go and register new endpoints for microservices. You have health and resiliency services. At the bottom, you have a certain set of conventions about how your microservice interacts with the rest of the world, and then the code that does anything and whatever you want. On the right-hand side, at the top right, you have a microservice that uses a client and some load balancing glue or framework and auto generation of proxy scripts to actually facilitate the calls to other microservices. So this is what a microservices architecture looks like at a very, very high level. And what you can see here is that we're introducing new concepts that you need to be aware of as a business to actually provide the capabilities and frameworks for microservices. What defines a microservice? I see we're also having problems advancing the slides. All right. What defines a microservice? Hopefully this is better now. A microservice can be looked at in one way, which is this way, which is essentially that a microservices is a service orientation plus the addition of DevOps plus the addition of containers. And I'm going to boil this down a little bit in the next couple of slides and try and explain it to those of us on the call that are coming at this from a business perspective, because these are three different concepts today that are, to some people, buzzwords, and to other people, very disruptive technologies. So when I look at microservices, when I look at DevOps, when I look at containers, each of these has a very disruptive effect on my business and my IT organization and the way that I operate. So let's drill into this into a little bit more detail. DevOps. DevOps is a very, very large concept, and a lot of people are trying to wrap their hands around what DevOps are, but essentially, or what DevOps is. But essentially, DevOps allows developers to interact with the infrastructure directly. What you're trying to do as an organization is shorten or simplify how applications are deployed into the corresponding infrastructure. If you think about how people have built applications in the past, they have potentially moved to an agile development model But when it comes to actually deploying the application into infrastructure, whether it be, dev or test or QA or production, it's very much a waterfall process, which requires a lot of time and a lot of effort and a lot of approval and a lot of people with their hands in the mix to actually deploy your code into a production environment. What DevOps tries to do is it tries to take that agile methodology and apply it all the way through from development through to the operational deployment of that code. And it does that by literally giving developers control over the infrastructure. So with a DevOps kind of environment, with a DevOps orchestration capability, developers define using metadata a model like maybe it's Tosca compliant, I don't know what it is, but or what people might be using, but essentially developers define a blueprint for the infrastructure that they need. And based on certain policies and constraints and processes, that blueprint automatically deploys that application directly into the infrastructure. And some organizations might only use that for dev and test. Other organizations might take it to the point where it actually deploys all the way into production. What this really does from a business perspective is that you need fewer operations staff. I'm not saying you're going to go out and fire everyone in operations, but what it does is it applies those people that you have to more relevant and more agile causes. So people aren't trying to understand what an application does and how an application is deployed, but rather they are providing that automated infrastructure and allowing the business to be more agile. Because if you can take an application from development all the way to production in a shorter period of time, ultimately you're going to speed up your feature release and the agility of your business. So DevOps just by itself is a whole topic that we could have a webinar on. But it's the support of microservices that is really, really interesting. And I'll try and tie this all together in a second. So just put in the back of your mind that we have this now automated way of taking applications and code and deploying them into an operational environment without all of the roadblocks that have existed previously. It's an automated way to deploy applications all the way into an operational environment. So then what is containerization? So containers are essentially a lightweight virtual machine. Everyone's heard about virtualization and how essentially you're taking a virtual machine, and a virtual machine can be deployed. You can deploy a lot of different virtual machines onto the same hardware. Well, containers are a lighter weight and smaller version of a virtual machine. I'm oversimplifying this for the sake of illustration. But essentially, the container is limited to just the application and the supporting environments and libraries. It does not include the operating system and the hypervisor framework. You can extensively run those small containers inside a virtual machine. They are efficient, they are easier to use, and they are much, much smaller in terms of their deployment because they're not dragging along an operating system, they're not dragging along a lot of the supporting infrastructure, they are not dragging along the complexity of a virtualization. They're faster to start, they're faster to stop, and they are quicker and easier to deploy, and you can get a much higher density of containers on a particular platform than you can virtual machines. They're a different concept, they exist at a different level, but they are smaller and more agile. And that really suits a microservices kind of environment because you're trying to create these small things. You're trying to divide your application up into these small building blocks and deploy them into the infrastructure. And microservices fits very well in with that containerization model, and containerization supports a microservices architecture. So you could look at microservices and say, well, microservices have been around for a long time. It's basically a service-oriented architecture. But it hasn't really become part of, or it hasn't really become so popular, for want of a better term, because the limitations of traditional operations and the limitations of your traditional deployment platforms have really limited or increased the cost of a service orientation to the point where it becomes impractical.
Hello,
but now that we have DevOps and can automate that deployment into an environment, and now that we have containers, the barrier to entry to a microservices architecture becomes that much lower.
I hear
you
you.
think about how
We are not able to hear the
three things
presenter,
have sort
right?
of collaborated together
Do they know
to
that?
make a microservice very, very
They
popular.
do. I think they're working on it.
It's very
Okay.
analogous to why APIs are so popular today. The reason that APIs are so popular today is that there is now a demand for APIs from the web frameworks and from mobile applications that have made APIs so popular. The same thing exists for microservices. Microservices have been sort of there in the background of IT for a long time, but the reason that they're so popular is because we have these other supporting technologies that makes them practical. So let's keep moving. The question we get asked all the time is, are microservices really any different to SOA? So there are some slight differences here. So I spoke about SOA, and I spoke about containerization, and I spoke about DevOps, but there's a couple of other things as well. SOA became very vendor and standards driven. That was never the intent, right? If you think about a service orientation, it's something that is technology agnostic. It's not tied to an enterprise service bus. It's not tied to SOAP. It's not tied to even XML, really. But what happened was, many, many years ago, the vendors drove SOA down a particular path. And they gave us SOAP and they gave us enterprise service buses. And it's a very, very heavy architecture, which is very contrary to microservices as they are today. Microservices are unabashedly anti-ESB. They are supposed to be lightweight, small,
The presentation
agile,
is on.
easy to deploy.
The slides
So
are
in
moving.
some ways, microservices are not SOA, or at least they're not that classical definition of SOA. But in other respects, there's sort of a reaffirmation of those SOA principles and almost a reaction or an anti-pattern to that traditional vendor-driven SOA. So you're seeing emerging de facto standards and frameworks. So there's no one going out there saying, well, this is the standard for microservices, and this is how microservices should communicate, and this is how microservices should be secured. We might see that, but it's kind of interesting that you almost want to allow people to build microservices in whatever way they want, and provide a sort of a lightweight framework around supporting that, rather than getting bogged down in a lot of standards and heavyweight platforms. That's just going to bog down implementation and increase the cost. So we're seeing the emergence of a lot of de facto standards and frameworks, and then people are dovetailing in this agile development, they're dovetailing in the DevOps, and they're dovetailing in containerization. So they're making it easy to deploy, they're automating the deployment, they're making it quick and simple to develop, and they are using de facto standards and frameworks for the creation of microservices. So I think personally, it is SOA, but it's possibly the way that SOA should have been. That is what it is. So let's keep moving. Analogous to that is people always ask me, what is SOA, APIs, and microservices used for? What are these different technologies really used for? I don't see the difference between a microservice and an API and a service. And I tend to categorize them in these three different ways. So SOA is kind of about reuse. So it's about supporting services that support multiple different applications. So the value proposition behind a service orientation traditionally has been, how can I create one service that 10 people use? APIs is about integration. How do I connect one application to another, and how do I support web and mobile applications? So it's geared towards easier and better consumption of those services. So an API to me is almost a superset of a service. You're taking a service that was inside your organization, you are productizing it by adding documentation and test clients and all of these kinds of things, and perhaps exposing it to a broader community. So the difference between an API and a service in my mind has got almost nothing to do with the technology. It's got to do with the business case. An API is about making money, and a service is about saving money. I know that these definitions are sort of not necessarily black and white or carved in stone, but these help us understand things. So an API would take an existing service or services within an organization and productize that and market that to its end consumer, whether that end consumer is also internal or as a partner community or even to the general public. You're going through a level of productization to create an API. And it's not bound to a particular technology at all. Microservices is subtly different. You may use things like JSON and REST, but it's actually got nothing to do with them. Microservices is about agility and scale. You're basically service enabling a piece of functionality, a component, to allow you to scale and rapidly deploy and rapidly revise that particular piece of functionality. So you're not doing it for the purposes of integration. You're not doing it for the purposes of directly supporting a partner community. You're building it to scale and improve or increase the cadence of your application development. And it's almost got nothing to do, I know there are underlying technologies, but that's not the point. The point is, how do I better build applications? How do I better scale an application? And the API and the services that come out of there, the interfaces, the protocols on the wire are incidental. It's a means to an end rather than the initial objective. So why are they so popular? Well, if you think about application development, and I drew these little funnels to illustrate my point here. If you think about traditional monolithic applications on the left-hand side, you have a bunch of features that you want to build, but there's basically constraints, organizational constraints and practical constraints that slow down development. You're only going to get a certain amount of features through this funnel within a particular period of time. With microservices, what you're doing is you're taking that big funnel and you're breaking it down into a whole bunch of little funnels. And these little funnels can, maybe not exactly, but you were going to get much greater velocity of features or a much greater cadence of development through a set of microservices than you would through the monolithic application. So the monolithic application is kind of unscalable in the long term. It's unscalable from a performance perspective because it's very, very difficult to scale that thing horizontally and vertically, practically number of CPUs, amount of memory, et cetera, et cetera, et cetera. But it's also unscalable from an organizational perspective. It's really hard to manage one giant project versus a whole bunch of small projects. You're going to get lower cadence and lower and slower features, feature cadence and release schedule. Whereas the microservices are far more scalable, both from a technical infrastructure perspective. You can fire up 20 versions or 20 instances of a particular microservice and load balance across them all. It's a smaller thing, it's easier to deploy, and it's easier therefore to scale. And also smaller projects are easier to manage. So a a traditional application is harder to manage, and a microservice-based application is easier to manage. But other things that are interesting is that a large monolithic application is very hard to learn. You're going to hire on a new developer, and they're going to sit down and say, "Wow, you've got 5 million lines of code in this application. Where do I even start?"
Nice talking to all you guys.
Setting up my development environment's a major pain. I have to.
At least
it's huge. It's burdensome. I spend 80% of my time getting the server to run, let alone writing any code. So microservices is much easier to manage and more importantly, it's easier to learn. People can grasp the functionality and the use cases and the concept behind a single microservice much easier than they can wading through a large monolithic application. So it's much easier to learn for new developers. And then of course deployment. It's slow to deploy a monolithic application. I mean, you've got, I don't know, a whole bunch of app servers and this, that, and the next thing. It takes a lot of time to deploy. Whereas a microservice should be built in such a way that it's actually quick to deploy. And you add in the DevOps and you add in containerization, and now it becomes really, really easy because you've layered in these other capabilities in your maturing operational organization, which makes it very, very simple to deploy and manage these microservices. You could apply DevOps to a monolithic application. I'm not objecting to that, but it's going to be much harder to do. Your scope of the effort is constrained and minimized in a microservices case. So how hard is it for people to adopt microservices? You might be thinking it's a great idea, so let's do this stuff. But there's a couple of prerequisites and there's a couple of barriers you have to overcome, I think. So essentially, you need some maturity of operations. So I personally believe that microservices are very difficult without things like containerization and DevOps. You're just not going to see the benefits, and you're not going to be able to get that cadence, that agility in the deployment of microservices. You're certainly not going to get, good scalability out of a microservices architecture unless you have or leverage DevOps and containerization. You also have to be willing to re-architect the application. It's fundamentally different. I have a few slides here later on that shows how you could approach the re-architecture of an application. I've kept it very, very simple, but hopefully I just leave you with an idea of the scope of change that would be required and some talking points around it. Because you have to re-architect this application, it has to be strategic, and you need to be able to invest in the app. This is not going to be something that is going to happen overnight. It's going to require some effort. So, when we talk to large Fortune 100 customers, it's an application that they need to be investing in. It can't be an application that they want to sunset over a period of time. It needs to be something that they're actively investing in, which means it needs to be strategic to their business. And that also means that it needs to scale. It either needs to support a larger and growing number of transactions per second, or it needs to be able to scale globally to support a global audience. And these are the kinds of things that, are prerequisites, I think, or at least sanity checks before going ahead and just, rewriting your application to leverage or to implement a microservices architecture. Additional guidance, well, you can pick this stuff up off the internet. It's out there. A lot of people talk about this. You've got the two pizza team size from Amazon. This is quite an admirable principle, I believe. You need to have smaller teams. And that's the other thing about a monolithic application is, even if you divide it up functionally, you ultimately have a large team. You have interdependencies that are tough to avoid, especially when it comes to deployment and release management. So taking the two pizza team concept is much, much easier if you implement a microservices architecture because you have a bounded set of concerns. And that makes things a lot easier to manage with smaller teams like a two pizza team. Microservices themselves are very focused on providing one capability. So micro doesn't necessarily mean that it's small, although it often is, but it's very singularly focused. It provides one piece of functionality, and it provides it very, very well. Like the Unix utilities, they do one thing and they do it very, very well. And you have to string them all together to get a whole bunch of functionality out of the operating system. So they're very singularly focused, and that minimizes ultimately its size, but it also minimizes the scope of testing and a lot of other things. You leverage lightweight communication protocols. Lightweight because if you have a lot of microservices, I read somewhere just yesterday when I was doing some research for this presentation, that a single page load on Amazon would call 150 services. Up to probably, and maybe there's a bit of exaggeration in there. But what it means is that you have a lot of built-up latency through all of those calls. You have to use asynchronous loading, and you'll see that when the page builds from Amazon. But ultimately, you want something lightweight in terms of a communication protocol. Let's not talk about XML and web services security here because that's not going to fly. What you're looking at is perhaps REST over HTTP, but perhaps other things like Apache Thrift. So you're looking at lightweight communication protocols that minimize that latency between these microservices. You're also going to use the right tool for the job. So you might use different platforms. You might change your database from relational to NoSQL or back to relational. But if you're looking at a microservices architecture, it's much, much easier to say, well, for this particular microservice, it's better written in Node, it's better running on Mongo, or hey, maybe it's better running on an app server. So it just depends on what is the right tool to deliver that piece of functionality. So that means that your applications might be made of a diverse set of technologies, which is fine. Microservices should also have their own data store separate from other microservices. And this comes back to, I'll draw up a couple of slides here, which shows how you migrate a typical application. But you're moving a lot of the logic, I use that term loosely, from the data tier up into the application tier. And you're sacrificing short-term performance for long-term scalability. So you're going to be doing joins in the application tier and building logic into that service to handle the transfer of data and those joins or paging events or whatever they might be. So you're going to be moving some of that logic up into the application tier to provide you with that scalability and sacrificing the efficiency of doing that join down in the data tier, which ultimately kills you in the end when it comes to scalability. The other thing is that a microservice owner is responsible for the life cycle of that microservice. They do everything. They do deployment, they do operations, and this comes back to my DevOps story from earlier. And they're also responsible to a large degree to testing. So you're going to come up with a small two-pizza team, includes QA, includes development, includes blueprint development for the microservice, maybe some guy that understands some operations about how do you use Docker, how do you deploy stuff into it, and so on and so forth, and create these self-contained teams that are capable of deploying the entire microservice and managing its entire lifecycle. So to try and wrap up this whole presentation, why should businesses really care about microservices? I've spoken a lot about different technologies and different trends, but basically it boils down to benefits and challenges. So the first is that you get improved agility. Your development organization can move faster to deliver features. And this is partly as a result of DevOps, and it's partly as a result of microservices. So you are able to build smaller things faster than you can build bigger things. And you can deploy smaller things faster than you can deploy bigger things. And you can also manage change and so on and so forth if you're looking at smaller things versus bigger things. Even if you add up all the smaller things, it doesn't, because they're kind of fluid and because they all move at their own pace, you don't deal with the sort of inherent waterfalls in deploying a monolithic application. Each one of these microservices is in essence independent. So it increases the agility and increases therefore the speed at which you can bring new features to market as a business. It also gives you better reliability. So you might think, yes, the monolithic application, everything is self-contained, it's all on the source. But when you look at it, a failure in one part of a monolithic application is quite detrimental to everything else. And you have to then patch or release another version of that monolithic application to fix that particular error. If you have a microservices architecture, you can scale up microservices maybe to overcome a performance constraint, or you can quickly version and change and bug fix a microservice without dealing with the operational waterfall that you have with that monolithic application. It's quicker and easier to fix a problem in a microservices architecture than it is in a monolithic application. You can identify it, you can isolate it, you can maybe compensate for it, and then you can fix it quicker and easier. So it gives you ultimately better reliability, and it certainly gives you better elasticity. So you can scale up any one part of your application because of a different load profile from the front end, for example. So you can say, whoa, the login is really suffering because I've got a lot of new users this month, or whatever the case might be. I can scale that particular part of the application so much better if I have a microservices architecture. Instead of stamping out 30 app servers running the big monolithic application just because one particular page or one particular part of the site is being used more than others. So you have much better elasticity with a microservices architecture because you have that containerization that allows you to quickly deploy 30 instances of a microservice into the infrastructure and load balance across all of them. You also get better global scalability. And this comes down to database, I think. In my mind, it's really difficult to globally scale an application that's bound to the database. The reason for that is that it is virtually impossible to create a multi-master global database infrastructure. It's very difficult and very time consuming. So if you look at a microservice and the way that it works, you put a lot less logic in your database layer. You put all your logic in the application tier. Each microservice contains all of its data and is isolated from other microservices. So you can leverage things like a NoSQL architecture or a sharding architecture in RDBMS much easier with microservices than you can with a monolithic application. So it becomes easier to scale this application globally than it would a traditional RDBMS-based monolithic application. So those are the things that gives you as a business: improved agility, better reliability and elasticity, and better global scalability. The challenges are more interesting sometimes. You're definitely going to, if you don't have a modern IT organization that is agile and implements DevOps and is looking at containerization, then you're going to have to introduce those concepts, which is going to be disruptive just by itself. I mean, DevOps is a disruptive technology. Containerization is a disruptive technology. And microservices is a disruptive technology. So you kind of have to have two disruptions before the last insult to injury. So there's quite a bit of restructuring of the IT organization to absorb these concepts. And it's around process, and there's going to be politics, and there's going to be resistance and all of those things. But you're going to be moving to an agile development shop. You're going to be implementing DevOps all the way through, hopefully, to production with some constraints and policies built around it and orchestration around it. And you're going to be implementing some kind of containerization model on top of what's potentially already a big effort for you moving to a cloud or virtual model. You're also going to be investing in new frameworks and platforms. I haven't spoken about this a lot, but you're going to be putting in you're going to be implementing and making recommendations potentially around microservices frameworks. And I showed you, one right at the beginning of my presentation. Maybe some people didn't see it because we had a problem with the slide, but you can take a look when I put out the movie. But essentially, there's frameworks and platforms and capabilities required to make microservices work. You need to have a registry. You need to be able to do load balancing. You need to have smart endpoints and dumb pipes. It's one of the principles of microservices. So you need to invest in new frameworks and platforms. The danger here is that you invest in too heavyweight a platform. There's going to be a lot of pressure from a lot of different areas to create a lot of bloat and a lot of hype around microservices. You really want to try and keep that lightweight. You don't want to have to implement a huge platform and a huge framework and standardize across the entire organization just to implement microservices. So I'd encourage you to look at it with a pinch of salt and figure out what frameworks and platforms you really need to enable a microservices architecture. I also mentioned a little bit the challenges between greenfield and re-architecting. If it's a greenfield environment, it's much, much easier to create microservices. If it's re-architecting, that's pretty painful, and I'll show you in the next slide. The other thing from a business perspective that you're going to have to think about is new skills. You're going to have to train people how to design microservices architectures. There are very, very few people who know what it means, and it's very, very difficult to scale that across your organization. The development practices do change. There's the frameworks and platforms that exist, and that fundamentally changes the way you're building applications and developing applications. And then last but not least, there's testing. The structure of the application has changed, so the testing changes. The QA people have to understand what a microservices architecture is and what that means to the testing effort so that things don't fall through the cracks. So let's quickly talk a little bit about re-architecting an application. I'm going to use a bit of an example here. So let's assume we have a monolithic application, and a monolithic application has 40 or so APIs supporting a web front end. And that monolithic application is consuming an RDBMS data store. And what I've done for scalability, as long as it's not too far apart, is I'm replicating between those two databases. It's a classic monolithic application which has inherent scalability problems. You can't move those things too far apart because data gets out of sync. And that monolithic application itself can't really scale all that well. You can start adding more and more servers, but ultimately you're going to get database contentions that limit the growth of that particular application, especially if you are in a cluster, because then those contentions exist with the constraints of the speed of light between the database instances. All in all, it's an ugly scene. So one way to start, or the one way that people typically start re-architecting their application is they start breaking it up. So they look at one application, a monolithic application, and they start breaking it up into its component parts. And each of those component parts provides a set of or one or more services. And each of those component parts now might start leveraging a different instance of a database. So you're going to start breaking your application apart. So say you have users tables and accounts tables. You're going to take that user table and you're going to put it into its own instance of a database, and you're going to take all the joins that you traditionally did using database statements, and you're going to take those joins out of that data access tier, and you're going to move it up into the application so that the applications themselves are doing the join between the user data and the account data. And that's going to inherently create some performance problems in the short term. But if you think about it, you can now scale that user service ad infinitum and scale the account service ad infinitum, and you're not going to get the database contention that you originally had. You can also start moving the data stores on a case-by-case basis, depending on what makes sense for the kind of data, to NoSQL data stores. And that allows you to implement the sharding and replication that those NoSQL service stores provide and the better ultimate scalability that they provide. It might not necessarily be suitable to the kind of data, but it does give you more options from an application architecture perspective. So that NoSQL store will ultimately provide you with an eventually consistent model for the APIs and services that you're exposing, which means you really have to change your client, whether it be your web application or your mobile application, to deal with an eventually consistent model. But if you're breaking up your application into these different microservices, or at this point it's probably a macro service, you can start dealing with those things. You can start moving logic out of your data tier. You can start pushing data into different data stores without having a mass migration of what might be 10 terabytes of data. And you can start using different architectures for different parts of your application. Ultimately, you end up with a set of services on the front end depends on a set of microservices on the back end. So you've now decoupled yourself entirely from the data. Each one of these different microservices has its own data. And they might be using RDBMS, they might be using NoSQL, they might be using heaven only knows what to actually persist and aggregate that data. But the idea here is that each of those things is independent. And you wire those microservices together potentially. This is probably a set of dependencies within those microservices, but you're exposing the same 40-odd APIs out of these 40-odd microservices that you were in the first slide. But what you've done now is you've migrated from a single data model, single database, a single data store, to a multi-data store, and also broken up your application into individual microservices. So you've split your data and you've split your application. And now that allows you to scale any one of these little things in a container as much as you want to support the needs of your front end. So as I said, if login all of a sudden peaks, then spikes, then you can deploy more and more of that particular backend functionality. So that's kind of the re-architecture of an application, and it might be impractical, but it does serve to illustrate the difference between a monolithic application and a microservices-based application. And I deliberately oversimplified this because I really want to get the message across about the business value and the business challenges associated with microservices. So with that said, let's look at some of the new skills. So I've taken this from Martin Fowler's website, but it very conveniently summarizes the sort of skills that are needed. And I'm not going to go into these things in a lot of detail, but these are concepts that people need to wrap their hands around to get an idea of, or to implement the right kind of microservice. Because you could take a bad application and make a bunch of bad microservices out of it. So you need to understand componentization. You need to understand, what it is to create an interface, potentially a REST interface, and leverage the best technology for the job. You need to organize these little microservices around specific business capabilities. You need to create products and not projects. So now your microservice is a product within the organization, and you take care of its entire life cycle, and you manage that, and it has its own SDLC process and its own requirements gathering and its own development and its own product management. It's a product. Each microservice is a product. You leverage smart endpoints and dumb pipes. So you don't care about necessarily about how messages go from one place to another, but you care about how do you orchestrate or how do you choreograph the different endpoints. So you have load balancing built into the framework, built into the endpoints. You have client-side stubs built into the microservice to call another microservice. You have a registry that contains endpoints. You have a concept of decentralized governance. So all of these things, like the registry, etc., patterns, libraries, are built into the actual service itself. You're going to be decentralizing your data management, moving to a domain-driven, design-bounded context versus a traditional data model that is more functional. You're going to be automating your infrastructure. You're going to be designing for failure. So you might implement, I've come across customers that have implemented, a framework that literally shuts things off randomly. And their architecture needs to be continually adjusting for and compensating for that failure. So they literally build failure in the testing into their infrastructure so that while they're doing testing, stuff fails all the time. Containers disappear, containers shut down, so on and so forth. Things start running slower, so automatically the infrastructure has to scale. So they test, or they design and they test for failure. And then you're going to be evolving that design as time goes by. So these are kind of concepts that monolithic application developers don't really think about or don't really have to understand, like domain-driven data design is not something that people really wrap their heads around until they have to. And it's quite essential for creating microservices that are organized around business capabilities. So if you don't understand these concepts, you're going to be building the wrong kind of microservice. And that's a problem in itself. So it's really important that you invest a certain degree in the training of your architects within the organization. So let's look at design. Traditional design and the oversight that you had is probably out of the window. Everyone is going to use the best tools to create the microservice. So you need to control what that microservice definition is, that interface. And that's the thing, as an architecture team, you're going to want to control, is what does that interface look like and what is its definition? There's this little saying over here. I see you have a poorly structured monolith. Would you like me to convert it to a poorly structured set of microservices? And that's absolutely going to happen unless you can really figure out what how that microservice should be designed in the right way. You need to facilitate design time review of available service and, of course, a way to force people to request a service. And this is a principle that's come down from the SOA days, where you kind of have a registry, and you look for these services, and if you don't find them, then you have to request a new service or a new interface, and somebody will say, yes, that looks like a good interface. Let's build that as a microservice, and there's probably some approvals that you have to go through. So it's interesting how microservices have reinvented the registry. It's more of a runtime discovery mechanism than a design time discovery mechanism, but it facilitates both models. You need some way of creating this request for service and discovering what services already exist within the organization. Especially if you think like an Amazon, one page load causes 150 services. You need to take some care about duplication within that environment. You need to adopt some conventions. So each microservice needs to be able to provide you with health, status, resiliency, a whole bunch of different informational services to allow the infrastructure or the framework to make a routing choice and a routing decision. So what that means is that you need to adopt certain conventions about the interface that you're exposing. It should have a health endpoint, it should have a status endpoint, it should have a, heaven only knows what endpoint. And you need to establish these conventions around the design of your interfaces and integrate that within your framework and your infrastructure to be able to make those routing choices and decisions during runtime. You need to be able to design for failure, and this comes back to the health status. So each service needs to provide its health, its status, whether it's up, whether it's down, whether it's starting, whether it's stopping, and there need to be events propagated about that so that you can manage failure. So if a service goes down or a service is struggling, you need to be able to respond for that. You need to design for robustness. So you might be proxying your services. So, there's the frameworks I talked about earlier. If you look at what Netflix is using, they use a product called Zool to actually proxy the service endpoint. And that gives you a way to do the routing and the resiliency on the back end. And then you need to understand distributed data design and domain-driven design patterns around data, because you need to ultimately separate your data out into these microservices, and each microservice needs to have a business focus. So it's kind of interesting how microservices affect design and the design patterns. Development team needs to know about all of these services. They need to know about libraries, strategies, patterns. They need to know a lot more about the SDLC process than they did with a monolithic application. I mean, developers used to build the application and say, okay, go for it. And people would have to figure out what that application did and what it needed to be deployed into an operational environment. Now that's the responsibility of the development team. The development team is going to work really closely with QA. If they don't already do to Agile, this is going to really make them work closer. And then they're also going to have to deal with development at development time, this eventual consistency model that comes from leveraging this distributed data model. Testing, all the traditional testing still exists, unit, integration, and component level testing. But there are nuances specific to microservices, and there's sites and presentations that other people in the industry have given that you're welcome to take a look at. I think more interestingly is the end-to-end and integration testing. Because you're creating a new framework and a new platform for microservices, this registry, these gateways, these libraries, these toolkits, those all have to be taken into account. These new paradigms, for want of a better term, around microservices have to be taken into account when you start QA testing. So the QA tools are going to have to use these frameworks and these tools or these platforms that you've put into place for microservices. All right, and that's the end of my presentation. Hopefully I described sort of the business value and why microservices are cool and important, and also describe the challenges that a typical organization would have implementing a microservice architecture. I think I've got a few minutes for questions, so let's see what we have. Let's see. All right. So the one question that's being asked is, well, what is the difference between a microservice and an API? And I sort of touched on that a little bit earlier. An API is a product that is designed for integration, whereas a microservice is something that is built to scale your application. And whereas a microservice might use an API, well, let's separate the concepts here. An API is a product, something that's going to provide you with business value that your partner or some eventual consumer is going to consume. That API is out there as a business channel and is built as a product. It has documentation. You do developer onboarding. It's a fairly coarse-grained function of your business that you expect people to consume, not necessarily within your organization. It may or may not use the same protocols and technologies as a microservice. But a microservice is built for a different purpose. It's not built as something that's supposed to be shared with a partner or something that's supposed to be shared with a larger developer community. It's built for purpose to allow a single application to scale. So a microservice is built to componentize one application, whereas an API is a product that's created to integrate multiple applications. So an API tends to be more coarse-grained. It tends to have a lot of marketing and productization put into it, and a lot of documentation and a lot of forethought. And there's probably a whole community of developers that are using this API. Whereas a microservice is far more fine-grained, and its purpose in life is to provide scalability. And it doesn't necessarily have to use the same protocols and technologies as an API, which might use JSON REST. It could be using something else. So I think it's more of a fit for purpose kind of statement than any kind of technology constraint, down in the weeds. Should microservices be written only as RESTful services? No, that's not a constraint at all. You can build microservices in a number of different ways. REST is certainly one model, but we've seen microservices architectures work very well using an asynchronous model based on AMQP. So there's no particular desire or particular guidance on building microservices as a set of REST APIs. That is more a fit-for-purpose kind of thing. So if it makes sense, if your microservice interface lends itself to a RESTful syntax or a RESTful paradigm, then go ahead and use it. The dangers of even JSON and HTTP is that it's not as performant potentially as a binary protocol, and something that's synchronous might not necessarily match your application architecture as well as something that's asynchronous. So it's a long answer, but I think that you need to be open to a lot of different choices and use whatever's best for the particular microservice. Is registry discovery a typical part of the microservices architecture paradigm? Yes, I think it is. If you look at all of the architectures out there, they have registry and discovery, primarily because the microservices architecture is designed to scale at runtime. So as you add additional microservice endpoints, you need some way of discovering and load balancing across them. And ultimately, you're designing something to be resilient. So as these containers that contain microservices come online and go offline, you're supposed to be able to automatically discover and route and load balance across them. So some kind of registry and discovery mechanism is part of that paradigm. Where does the calling and orchestrating of different microservices happen? It happens within the microservice. You're not going to be buying a BPM platform or an orchestration tool to orchestrate microservices. It's done in code. So this is a new way of writing applications. We're not introducing an orchestration tool into a microservice because that's just going to make it bigger and more clumsy. So what you're essentially doing is, you're creating some kind of a client or a gateway for all outbound calls out of a microservice container that call other microservices. And then in code, you are essentially doing the orchestration of that and turning around and providing a different microservice. Now, I think at some point, orchestration of microservices is something different to the orchestration of APIs. APIs are less granular. They're more coarse-grained. So it makes sense to do orchestration using a tool, visual drag and drop orchestration editor at that point because they are much more coarse-grained than at a microservices level. At microservices level, you're going to be writing code to orchestrate stuff. And it's orchestration is not really the right term, but you get what I mean, I think. To distribute the load to microservices, are we using messaging or load balanced RPC? I think I don't think that it's a load distribution issue whether you choose something like HTTP versus AMQP. I think that's the origin of your question. I think that using synchronous versus asynchronous and the type of protocol you use or the type of MIME type that you use depends on the latency tolerances that you have and the type of application, whether it's inherently asynchronous or whether it's inherently synchronous. So I think that that's what determines the protocol. I think that how you interact with the registry and how you do load balancing is going to be fundamentally different. So if you think about using AMQP and how you add additional targets into AMQP, it's different to how you might be load balancing HTTP. You might be programming an F5 load balancer versus an AMQP broker, if that's the right terminology. So I think it's different. Let's see. When data is local to a microservice, then how is data coherence ensured when services go up and down? Well, ultimately, it depends on the kind of data layer you have. If you're looking at something like a Mongo or Cassandra, then it's going to depend on what your write strategy is. So if it goes down, it's possible that you lose data, and you kind of have to design your application around that so that it is tolerant of that particular failure. If you're doing writes consistently, then hopefully your underlying data store or data infrastructure can actually manage some of that for you. But even if you have an RDBMS-based application and you do a write and the whole thing explodes, you're not really going to know where you ended up. It's going to depend on where that failure occurred in your application. So I think that the data coherence is something that's inherent in the design, and dealing with the failure of data coherence is a trade-off between the speed of write consistency and the replication model that you have within your data structure. So it's going to change. I think that's all we have time for. It's hopefully interesting, and I'm glad everyone could join.